Hello again. Right, this video is just a simple video on showing you how to use the A.D.T function of the tester. The A.D.T is the active device test, and it allows you to test digital logic devices on the board while it's powered up. So it needs to be active for it to work, and I'll show you how it works. The A.D.T is a separate piece of hardware that you have to plug in. Now I do supply, with the tester, I supply a little board with a test clip attached to it and a couple of connectors that you need to plug in. So when you use the A.D.T you have to unplug, at the moment you have to unplug anything else you've got plugged in. The probe's different, the probe can stay plugged in, but anything plugged into connectors A and B has to be removed. Now I'm going to use this one here. As you can see, if I can get it in front of the camera, this is the one I used myself, and you've got a 20-pin test clip. If I can get it in front of the camera, okay, and there's two connectors that go onto A and B. So what we'll do first of all is I'll plug these into the tester. So I'll swing this round and hopefully we'll get this to work. The tester needs to be powered up at the time. It doesn't matter if it's turned off or turned on, you can do it either way. So we'll plug that one into connector A and that one into connector B, like so. And we'll put the test box down somewhere so we can use it. Now, to get the A.D.T to work, we need to actually start the A.D.T function. So again, going onto the test main screen, we'll click the blue A.D.T button down the bottom. Now, because I'm on a separate monitor, I'll get two screens appearing, and I'll bring the other one down. As you can see, there it is there. Okay. Now, if you're on the LCD, basically this will just go over the other one, so you'll only have the A.D.T on the screen at a time. But because we're on a separate monitor, you'll have the separate screens. So when you want to obviously stop the A.D.T, you click the button there and it goes back to the main test screen. So we'll just open it back up again. I'll put it over the other one so we don't confuse anything. We'll bring it down a wee bit. It's just my camera won't do it. And that's the A.D.T running now. So the first chip we'll check is a 74LS157. So what we need to do is we type into the device box the chip number 74LS157, and it's a 16-pin device, so we need to tell it it's 16 pins, and that's it. That's all we need to do. On the actual board, if I turn this down, hopefully we'll be able to see this. This is the Pac-Man board as featured before. With the test clip, we're going to check this chip here, which is a 74LS157. So we put the test clip on now. There is a point, one pin has to be always on the ground pin, which will be that one. I've marked this one here with a white, so that's pin 1 of the test clip. So pin 10 will be that one there. Okay, right, pin 10 is that one there. There's the white one, so pin 10 has to go to effectively pin 8 of the chip. So you have to make sure the orientations are right. If you get it round the wrong way, it won't work. So we'll just clip it straight over. The board is actually powered up at the moment, so there doesn't make any difference to it. As you can see, it's clipped on. And then we go back to the A.D.T screen. As you can see, hopefully that. And at the moment, we've got a blank 20-pin chip, and all the pins are green. You might get different states if you start it up, but anyway, that's it. Obviously there's the ground pin, there's your 5-volt pin, and similarly to test the chip we just click test, and there you go, it's passed it. It says up there that it's passed, and what it's done here is it's reduced the chip down to a 16 pin. It's highlighted obviously the fact it was a 20 pin, and also it's put in the chip basically a logic diagram of the chip itself. So you can see it's showing you what all the pins are connected to. It's come up with different states. When it's green, the pin's obviously low. When it's red, the pin was high. And for that pattern, it's obviously checked that against its known tables, and it's decided it's passed it. You can check that against a truth table as well, and you'll find that will be correct. If you want to do it again, you just do it again and you'll get a different pattern, and it's passed it again. Because this is a live test, the chips are running, and that means you can get a random result any time, because at any given moment in time the chip will be in a particular state, and this tester will pick that up and it will apply known truth tables to it and obviously decide whether it passes or fails. So you can do that as many times as you like. Okay. If you want to do another test, stuck check, which is this one here, that goes around all the pins and has a look and it looks to see if a pin is actually stuck. So it could be stuck high, it could be stuck low, and that will show up whether you got a stuck, say, address pin or whatever else. So if I do stuck check, you'll see it will take a bit longer this time, and it will go through 3940 tests. When it gets a pin that actually changes state, and it's done it that time, it will actually change the pin to purple. So purple pins are actually passing because it's indicated that when it goes purple the pin has changed state, so clearly it's not a stuck pin. If the pin stays a particular colour, it will indicate those pins could potentially be stuck. You'd still need to check them, but it's just flagging up pins that don't change state. So some of them could be tied high or low, which are absolutely normal, other ones might not be. So you need to, when you run that check, whatever result you get, you might want to just check it against, put a scope on it or use the logic probe, etc. and just check it before you decide the chip is faulty. The short check does a stuck check again, but the short check looks for two adjacent pins that could be stuck together. So for example, pin 1 and pin 2, they could have a short between them, in which case it will flag these two pins up. So if we run the short check, you'll see that change. And pins that are potentially shorted will flag up as yellow. You'll only get the results once it finishes. And on this occasion, there were no pins that are shorted together. So, oh, there you go, it's done it. So you've got two pins there that are yellow, so pin 12 and pin 13 potentially could be shorted together, and pin 9 and 10, they could potentially be shorted together. The purple pins obviously have changed state, green and red pins haven't changed state, and you obviously doesn't check the 5 or the 0 volt lines. So that's it checking that chip. We'll go on to another chip now. Let's try, we'll go to say a 74 LSO2, if I've got enough time on this video. Change it to there, and change it to there, and clip it, and we'll clip it onto an O2, which is this one over here, and we'll run the test again, and straight away it's passed that one. There you go, and it's giving you a different logic diagram in the chip, and you can again check that. Okay, so that's it running the A.D.T. The next video I'll show you the A.D.T. again, but on how to actually load in truth tables and how to change the diagrams. Thanks very much.